Okay, this is the M1 paper from October 2020. It's question number 3. This question is a statics question. We've got a particle held in equilibrium there. We're going to be using a force diagram. We're going to be resolving. There's going to be friction involved. But let's have a look at it. Let's get started. So it says we've got a particle of mass 10 kilograms placed on a rough plane. Well, that's interesting because that means that we'll have friction involved. Plane is inclined at alpha where tan alpha equals 3/4. Yeah, that's pretty standard. Particle is held in equilibrium by this force P here. Okay, and it acts up the plane as we can see in the diagram. Line of action of the force lies, yeah, all that stuff's just our standard information we're given. And it tells me coefficient of friction, mu is equal to 1/2. Right, what have we got to find? It asks me to find the normal reaction between the particle and the plane. And actually, I'm going to get started with that before I do the second 2 bits here, which talk about the greatest value and the smallest value of P. Let's draw our diagram out. Let's get everything up and running, and then we'll start talking about B and C after we've done A. So I would always draw out my own diagram to put forces on, just so that I can put the forces on and resolve them quite clearly. We've got that angle there is alpha. We've got the particle P here, which has got a mass of 10 kilograms, so it's got a weight of 10 G acting down there. As soon as we got that, obviously we'll have a reaction force if it's touching a plane, perpendicular to the plane. And they've told me that we've got, sorry, that force acting the wrong way, force acting up the plane P there. And because they tell me it's a rough plane, I've got friction. I'm not going to put the friction on yet. Let's just do the rest of it. Let's do the R bit, and then we'll come back and do that. So what I need to do is I need to take this force, and I just need to resolve it parallel and perpendicular to the plane. I'm interested in those two components of the 10G. This angle is 90 minus alpha, which means this angle is alpha, which means this is 10G cos alpha, and this is 10G sine alpha. None of that should be a shock to you. Also, let's take care of the fact that tan alpha is equal to 3/4. This is all standard stuff, done this lots and lots of times. Look at any of my other videos, you'll see lots of times I've repeated myself on this work. If alpha is there, tan is opposite over adjacent. Pythagoras will give me that's 5, or you can just know the 3, 4, 5 triangle. I do. I encourage my students to as well, which means then that working out sine alpha and working out cos alpha using that right angle triangle are opposite over hypotenuse and adjacent over hypotenuse. And if we haven't already, let's put mu on as being equal to 1/2. So I'm going to do part A first of all, which is to find the normal reaction between the particle and the plane. Otherwise, I would have put all my other forces on, my frictional force on. But let's do A first of all, because I can do that without having the frictional force on. So if I resolve perpendicular to the plane, which means in this direction here, I've simply got that because the force is in equilibrium, even if I say F equals ma, I'm just going to get that R is equal to 10G cos alpha. And remember, we've just worked out what cos alpha is. It's 4/5. So it's 10G times 4/5, and that works out to be equal to 8G. So brilliant. I can do that straight away for part A, 2 marks there. Before I now consider the difficult part of the question is part B and part C then. So it now talks about the greatest value of P and the least possible value of P. I'm going to do both of them sort of together here, and then we'll do the work for them. And it's the idea of the fact that this particle, it tells me it's in equilibrium, so I know it's not moving, but P could still take different values. What we could have is P could be pushing up here with a force so hard that the object is just about to move up, but isn't quite big enough. Anything more than, 0.1 bigger for P, and it would actually start on its movement up there, but it's still holding steady. That's the greatest value that P can be. If that does happen, if we did have that situation, then because we'd be looking at P moving in that direction, the frictional force, and this is the key, the frictional force for a maximum P, the frictional force would be acting in that direction. That's where friction's going to be, because P is on the point of moving up, even though it's not moving up. So I'm going to do that to work out part B, the greatest possible value of P, but then following exactly the same logic through, what I could do is I could say P was a force that was holding it up, but was only just about holding it up, and that now my object P is just on the point of sliding down. It wants to slide down, and if P was 0.01 smaller, then it would start moving downwards. That will be the least possible value of P. So at that stage, friction would start opposing motion then, and we'd have friction in the opposite direction. What that means, if you understand that then, is that when I'm going to be doing part B and part C, when I'm going to be doing part B, if the object is going to move anywhere, it's going to move upwards, then it's okay to say friction is going down. So now when I do my resolving parallel to the plane, that's the situation I'm going to have. And so let's actually do it. Let's do it and show you. So for part B, and now I've explained it to you, I sort of need to explain it to the examiner then. For maximum P, particle is on point of moving up the plane. So therefore, friction will oppose motion. So now if I resolve parallel to the plane, handwriting, parallel to the plane, just go back and look at that. Those are the forces. I've got F equals ma. It's on the point of moving up the plane, so I'm going to get that F and the 10g sine alpha are acting in the same direction. We know that it isn't actually moving, so if I do F equals ma, I know that the forces are in equilibrium, so I can say that the P is equal to the 10g sine alpha plus F. 10g sine alpha I know, F I need to find. How am I going to find F? Well, F is going to be equal to mu r. That's going to be the same, doesn't matter which way round the object is moving. So F is going to be a half, because that's mu, times by the r that we just found. So that works out to be 4g. So that'll be constant for whether it's moving up or moving down here. So now if I substitute that in, P is equal to 10g sine alpha, but that's 10g times 3/5 plus my 4g. And if I tidy all that up, that's 6g plus 4g. So P is going to be equal to 10g. If I do part C then, and I'm looking at the least possible value of P. Now, I'm not going to change my diagram here, just in terms of timing and trying to model to you guys properly. I would not now redraw this diagram and do everything with that. That would be just crazy. It would take me too long. But basically, I've got this situation instead. So all that's going to happen is the P and the F are going to be in the same direction, and the 10g sine is going to be in the opposite direction. In terms of making that clear to the examiner, don't want to spend too long doing it. I can just say for minimum P, friction will now act in the opposite direction. Okay, the examiner's either going to help me in terms of getting my marks for the final answer anyway, so I don't need to spend ages trying to explain it. Oh, I've explained it to you, but that's because you guys might need help with this. But in terms of the examiner, I think that's more than enough. Resolve parallel to the plane. It's in equilibrium again, so even if I do F equals ma, I'm going to get this time that P plus F is equal to 10g sine alpha, okay? The F is now going in the opposite direction. The F hasn't changed because of any of the information we've just done there, so I'm not going to redo that either. We've just spent a lot of time conscious of how long this would take in the exam. So I get that, I get P that 4g equals 6g, which means this time P would work out to be equal to 2g for the minimum value. Okay, hopefully that will make sense to you in terms of the explanation of that. Maybe you need to go back and look at the video more than once, but it's a nice question for just explaining this idea about the maximum and the minimum that P could be, and still the object is moving, it's still held in equilibrium. Okay, hopefully that makes sense.